Good morning, everybody. So today I'm going to start with a new instrument, and that is the centrifuge machine. Okay, I think you might have all used a centrifuge machine in your college, in your laboratory. Okay,
Yes, sir.
can you tell me what was the use of the centrifuge machine? Why did you use it?
Separation of particle with the help of
Separation,
centrifugal force.
separation of which particles?
With the help of centrifugal force.
Okay, which particles are you separated?
DNA, RNA separation.
Okay, DNA, RNA.
Protein, yes.
What about bacteria?
Isolation of E. coli from bacteria.
Isolation of
Isolation of DNA from E. coli bacteria. Yeah, any bacteria.
DNA. Have you not used it for separating the bacteria?
Yes, sir.
Okay. Can you all see me?
Yes, sir.
Okay, I don't know why I can't see myself. Okay. Anyways, so centrifugation or a centrifuge is a device which we use for separating particles from a solution. Okay, rather, I think this word is wrong. It should actually be, what should it be instead of solution? As we use centrifugation to separate insoluble particles, isn't it? Or soluble particles. Yes, insoluble or soluble.
Insoluble.
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 Okay, so I think I should write that also. Insoluble particulates from a solution. Was that correct?
Yes.
Yes. So bacteria, do we call bacterial culture as a solution? Solution of bacteria?
Yes. Suspension, sir.
Suspension, any particle in suspension. Any.
Suspension, that is the right word. Okay, just a minute. Okay, so I should write here suspension, isn't it? Instead of solution, because it is a liquid or aqueous liquid which contains the insoluble particulate. So it is a suspension. Let me save this, whatever changes I have made. Okay, so centrifuge is a device which we use for separating insoluble particulate matter from a suspension. And this particular separation process is dependent upon the sedimentation rate. Okay, we separate the particles on the basis of different sedimentation rate of the different particles. Okay, and the sedimentation rate itself is based upon the different properties or different features of the particulate matter. For example, it could be the size of the particles, it could be even the shape of the particles, and most importantly, it is based upon the density of the particles. Is it okay? And then it is also dependent upon the viscosity of the medium, because if the medium is too viscous, then you would require a larger force, larger centrifugal force to separate the particles. Okay. And then it also depends upon the speed of the rotor, or how much is the RPM. Do you know this word RPM?
Revolution per minute.
Yes, revolution per minute. Okay, so that is nothing but the speed of the rotor, or velocity, you can say. Okay, so two particles which are having different masses or different densities will settle in a particular tube or a centrifuge tube at different rates and that will be in response to the centrifugal force which is applied. Is it right? So any difficulty you have concerning this statement which I have made? Everybody has followed it? Hello, Shraddha Joshi.
Yes, sir.
Okay, any difficulty? हे कळलंय का सगळ्यांना?
Yes, sir.
Okay. Then we move on to the next slide. And that is again telling you about what is centrifugation. Okay. So we are going into little more specific aspect of the topic. Okay. So any object which is moving in a circle, any object means what? Any particle in a liquid, right? Which is moving in a circle at a steady angular velocity is subjected to an outwardly directed force, isn't it? You can imagine this. I think you have already studied in physics about the centripetal force and the centrifugal force, isn't it? So if anything is moving in a circular fashion, okay, then it is subjected to an outward movement, isn't it? Now this outward movement is called as the centrifugal force, and the magnitude of this force depends upon the velocity. Now here we call it as the angular velocity because the motion is a circular motion. Okay, so the force will depend upon the angular velocity, and it depends upon the radius of the rotation. Okay, so when I say angular velocity, it is in terms of what is called as radians. Okay, that is omega. Omega is the symbol for the angular velocity, and it depends upon the radius r of the rotation. Okay, this radius is in centimeter. And therefore we write this expression, the force, that is the centrifugal force, is equal to omega square r. In fact, I should write one more thing here, and that is the mass of the particle. Okay, so it is usually this term, mass into acceleration, and the acceleration here is given by the term omega square r. Okay, now how much is this force compared to the Earth's gravitational force? Because you know that any heavy object is going to fall to the ground, isn't it? And that is because of the gravitational force. Now, when we put particles in a liquid, these particles are also going to settle down, or they are going to sediment depending upon their own density, isn't it? But the problem with bacteria is that bacteria have a certain density, and because of that, they cannot easily settle down at the bottom of the liquid on their own. Okay, by virtue of gravity, they will not come down to the bottom of the container, isn't it? Have you experienced this? If you take a culture of bacteria, do the bacteria settle down in the flask or in the test tube? Yes, Inamul? Inamul, can you hear me? Shamim?
Yes, sir.
Okay, what happened to Inamul? Looks like he's busy somewhere. Okay, Shanim?
No, sir. I was having connectivity issues.
Okay. Yeah, so what was my question? I forgot. What was my question?
So bacteria, does it settle down? Or
Yes. Yeah, if you take a culture of bacteria either in a test tube or in a flask, then are the bacteria going to settle down on their own? Will they settle down?
no, sir.
No. Who wants to say yes? Will a fungal culture settle down?
No.
No. Have you actually worked with a fungal culture anytime?
Sir, I think they remain in thread-like structures.
Yeah, I couldn't hear you properly. Inamul? Yes.
I think, sir, fungal cultures remain as thread-like structures.
Yeah, but
in
will
the
they settle down or will they remain floating?
Sir, they will remain suspended in the
Okay. Okay. So I think you have not worked with a fungal culture, or you have not compared a bacterial culture and a fungal culture. Mostly the fungi will tend to settle down at the base, okay? But a bacterial culture will not settle down, okay? Because their size is too small, their mass is too less, okay? And therefore, by simple gravity or gravitational force, they are not going to settle down. And that is why we have to use a centrifuge machine to allow the particles to sediment. Okay, normally the particles which are not going to settle down easily just by the force of gravity, we have to use the centrifugation machine or centrifuge machine to separate them from the liquid. Okay, so now the question is, how much is this force or centrifugal force compared to the Earth's gravity? That particular term is called as the relative centrifugal field. So when I say the word relative, it means we are comparing it with some other kind of a force. So here the centrifugal force is compared to the gravitational force. Okay. And when compared to the gravitational force, how many times it is more than the gravitational force? That is called as the relative centrifugal force, okay, or relative field, we can say. Okay, so for example, I'll say that if we use this term RCF for a relative centrifugal field, then this RCF is equal to the centrifugal force divided by the force of gravity. Okay, so that will give us the number how many times the centrifugal force is compared to Earth's gravitational field. Okay, so if we have this g is equal to small g is equal to 980 centimeter per second square. Okay, that is the acceleration, gravitational acceleration. Okay, then this RCF will automatically become omega square r. I should also write here mass. Okay, so mass into omega square r is the centrifugal force, and this centrifugal force divided by 980, that is the Earth's gravitational field, that will give you the relative centrifugal force. Okay, in short, relative centrifugal force is the multiple of the acceleration due to gravity. Have you all understood it?
Yes, sir.
Yeah, so we have two types of expression when we are centrifuging something or separating a bacterial culture, okay, for example. And we are going to use two types of terms. One is called as the RPM, that is revolution per minute. Okay, that will give you about the speed of the rotor in 1 second or in 1 minute, how many times the rotor is actually rotating, isn't it? That is one kind of an expression. And the other is the G. Okay, that is G is the times of the number which tells you relative centrifugal field. That is how much times you are employing the centrifugal force as compared to the gravitational force. Is it okay? Now this particular figure shows you a particular diagram. Okay, so this diagram tells you about the relationship between the radius of the centrifugal field, okay, radius of the centrifuge or rotor, you can say, right? And then I have written here the RPM, that is the speed of the rotor. Say for example 200, 500, 1000, 2000, 3000. These numbers are telling you about the speed of the rotor. Okay, and somewhere here in the between, now if you compare this, so for example, if the speed radius of rotation is 75, okay, 75 millimeter here, okay, and then here you have the RPM speed of the centrifuge, that is say 2500 RPM. Okay, now if you connect these two lines, then it is intersecting this third line, which is called as the relative centrifugal field. Okay, and directly from this diagram you can get what is the RCF. That is, for example, here it is about 400 into G. 400 into G, that is the relative centrifugal field. Okay, so this kind of a figure is called as a nomogram. Okay, nomogram is used for determination of the RCF. Okay, or if you know the RCF, it will help you to find out the RPM speed. Okay, but normally in a centrifuge machine, the RPM speed is given. Okay, so you can adjust your speed in RPM, and of course you know the radius of the rotor, or radius of the rotation, because that is given in the manufacturer brochure, you can say. Okay, so for every kind of rotor, the radius of the rotation is already known. Okay, so if you know these two terms, then you can easily calculate what is the relative centrifugal field which is acting on a particular particle which is being separated from a liquid. Is it okay? Okay, this is another diagram. I won't go into that. Okay, and then the question about why we need a centrifuge, why we need to use centrifuge machine. I have already told you the answer, that the particles that we are interested in as a microbiologist, okay, we are going to separate viral particles maybe, or bacterial cells, or fungal culture. Okay, so in order to separate these microorganisms, the gravitational force is not enough. We have to employ higher force, okay, higher field, and that is possible by using a centrifuge machine. Okay, as an example, I can also tell you that if we are using an ultra centrifuge which has a very high speed, okay, the speed is of several thousand revolutions per minute, and that leads to getting RCF. Okay, that is about 3 lakh time 3 lakhs times the acceleration due to Earth's gravity. Okay, so that is 3 lakh into G. Okay, or sometimes even more than that. So that is the kind of a centrifugal force we can generate by using a centrifuge machine, and therefore small particles or bacterial cells can be easily separated, and viruses can be separated using an ultra centrifuge. We cannot use a normal centrifuge for separating viruses because the size of these particles is too small, and therefore we use an ultra centrifuge which gives a very high G factor for the separation of these tiny particles. Okay, is it clear? Okay, then we are trying to understand now what are the different kinds of forces which are acting on any particle which is in a liquid. Okay, so for the time being, just forget that we are studying centrifugation, but any particle which is placed in a liquid, okay, that particle is going to experience three kinds of forces. Okay, number one, the first important kind of a force which that particle will experience is called as the force of gravity. Okay, that is also denoted by Fg, capital F and capital G. That is the subscript. Okay, capital G is a subscript. So Fg, any particle which is in a liquid will tend to sediment down. Okay, if it is a heavier particle, of course I'm not talking right now about bacterial cell, because a bacterial cell will not sediment easily in a liquid. Okay, but if it is any other particle which is heavier than a bacterial cell, then that particle will tend to sediment in the liquid towards the bottom of that container. It may be a test tube, or it may be a flask, or anything else. Okay, and that will take a certain time, say it may be in minutes or it may be in hours, depending upon the mass of the particle. Okay, that was about the force of gravity which I told you. Then there is another force which is called as the force of buoyancy. Okay, and that is denoted by capital FB. Can you see that here on the screen? FB is the force of buoyancy. And what is buoyancy? It is a force which tends to push the particle towards the surface of the liquid. Okay, and that therefore the particle will tend to have a lesser weight in liquid than in air. I think you might have experienced this, that if any object, okay, you can feel the weight of the object. Okay, and if you put that object in a liquid, then it will tend to have a lesser weight. Okay, and that is because of the force of buoyancy, because the liquid will try to push the object towards the surface of the liquid. That is the second force. And the third force which a particle in a liquid will experience is called as the viscous drag. Okay, viscous drag. And this is also denoted by FD. D stands for the drag. Okay, and this is the force which will oppose the movement of the particle. So you can imagine that once the particle starts moving down, okay, in a liquid, then it will experience a force which is acting in the opposite direction. Okay, just as you are, if you can imagine that you are driving a vehicle, okay, a motorcycle or something, and then while you are, if your speed increases, then you will feel a lot of air pushing you back. Okay, or that is the force which is trying to oppose your movement, isn't it? Or you can also call it as the resistance. Okay, you can experience resistance when you are moving on a vehicle. So similarly, when a particle actually starts sedimenting down or moving down in the liquid, then it will experience a force which is acting in an opposite direction. Okay, and that force will depend upon the velocity of the particle. So more is the velocity of the particle, more will be the force which it will experience. Okay, and less is the speed, then less force it will experience. Okay, that is the force of resistance or the force of viscous drag. Okay, now this force will depend also upon the size of the particle or shape of the particle. It will also depend upon the mass of the particle, because more the mass, more will be the sedimentation rate, and more the sedimentation rate or sedimentation velocity, more will be the force of viscous drag. Okay, this force is also dependent upon the viscosity of the medium, right? So if the medium is a denser medium or more viscous medium, then the particle will experience a greater force in the opposite direction. And if the liquid is like water, okay, with minimum kind of, you can say, viscosity, then the force which is experienced by the particle also will be less. Is it okay? Any questions so
Yes,
far?
sir.
Aishwarya entered little late, so Aishwarya, are you following what I'm saying?
Yes, sir. Yes.
There are, I think, some
No,
internet issues.
I haven't entered late, sir.
Yeah,
My
internet.
connection just got lost.
Yeah.
Yes.
Okay. Okay. So these are the three types of forces which any particle will experience in a liquid. The force of gravity. So the particle will, because of this force, the particle will tend to go down to the bottom of the container. Then there is a force of buoyancy, because of which the liquid will push the particle towards the surface. Okay, and the third force again is the viscous drag, which is the resistance which is felt by the particle if it is moving, if it is actually moving in the liquid. For example, if the particle is not moving, if it is stationary, then it will not experience this force. But if it starts moving, then depending upon the sedimentation velocity, it will experience a more or less kind of a viscous drag. Okay, and then you will again realize that out of the three forces, one of the force, that is the force of gravity, is going from top to the bottom. Okay, trying to move the particle from the top to the bottom. And the other two types of forces, that is the force of buoyancy and the force of viscous drag, they are both acting in the opposite direction, and they are trying to push the particle upwards. Okay, they are actually acting in the opposite sense, right? So then we go to what are the important factors which are useful, which are going to determine the sedimentation of a particle in centrifugation. Okay, so here are some rules which tell us that if the particle is more dense, okay, density is denoted by the term rho. I think you know about this term rho. Okay, this is not p, but it is a Greek alphabet, that is rho, and small p here stands for the particle. Okay, so density of the particle. If the particle is more dense, then it will move faster. Okay, it will sediment faster. For example, if I have an iron piece, okay, piece of iron, okay, it will probably sediment very fast. But if I take a piece of cotton, okay, cotton, which is having probably the equal weight as that of the iron particle, iron piece, the iron piece will move faster than the cotton piece, because the density of the iron is more than the density of the cotton. Is it right? Okay.
Yes, sir.
Yeah, so I have only 10 minutes now for this meeting. So what do I do? Do you have another lecture? Did Buktar madam tell you anything about her lecture?
No, sir.
Let me just check the WhatsApp. If there is any notice given to you. Please hold on. for a minute. Okay, I think there is no meeting, no message as such from madam. Can you see my WhatsApp also on the screen?
Yes.
Okay,
Yes,
okay. So whatever I show here on the screen, that will be visible to you. Is it right? Okay. Yeah. So I was telling you that the particle will centrifuge or it will sediment faster if the density of the particle is more. And then if the mass of the particle is more, yes, again, it will move faster. Then if the density of the medium, okay, here I have called it as a buffer, but it could be any medium. It could be plain water also, okay. So if the density of that medium is more, then the particle will move slowly, right? And here I have denoted the density of the medium as rho s, okay. So s here stands for the solvent actually, but we know that this is not a solution actually, okay, but still that term s is there. Rho s stands for the density of the medium. Then if there is a greater frictional coefficient, okay, or more friction is there, that is to say if the viscosity of the medium is more and therefore the friction also is more, then the particle will move very slowly, right? If the centrifugal force is bigger, okay, or greater, then the particle will move faster, okay. And then if the density of the particle, now this is very important, if the density of the particle and the density of the medium are equal, then the particle will not sediment, or rather the rate of sedimentation of the particle will be zero. That is, the net rate of sedimentation will be zero, and therefore the particle will continue to fall to the bottom of the liquid, okay, with a constant velocity, okay. That is called as the terminal velocity. Okay, so just remember this particular sentence, that if the density of the particle and the density of the medium are equal, then the net rate of sedimentation will be zero. And whatever terminal velocity the particle has already achieved, with that velocity, it will continue to move towards the bottom. That is to say, there will be no net acceleration in the movement of the particle. Okay, so no acceleration, but constant velocity. Okay, I think you already have studied about this, that acceleration is the rate of change of velocity. Okay, so zero acceleration doesn't mean that the particle has already stopped moving. The particle is moving, but the acceleration is not there, right? But with a constant velocity, the particle will keep on moving. So this is whatever I have discussed here in this particular slide. This is all an answer for this particular question. That is, what are the different factors that affect the rate of sedimentation of a particle? Okay, and that is very important. This may be asked in the exam in whatever form. If it is an objective exam, there will be multiple choice question, or it could be
size of particle.
yes, yes.
Size of particle.
Size of particle, yes, definitely. If the size of particle is greater, then also it will move faster. Okay, but then actually size, mass, these are all terms which are relative, and therefore I have used the term which is density of the particle, which is a more apt term, I would say, a more correct term. Okay, instead of talking about the density and the volume of the particle, okay, size of the particle, we are using the term density of the particle, because what is density?
Viscosity.
Yes, do you know the formula for density?
Mass per volume.
Mass
Yes,
by volume.
yes, mass by volume. Very correct. Okay, so mass and volume, these are all related to the density, or rather density is dependent upon both mass and volume. And therefore, instead of separately saying that the particle will sediment depending upon the volume of the particle or depending upon the mass of the particle, it is more correct to say that it will sediment depending upon the density of the particle, because density will cover both the aspects, the size as well as the mass of the particle. Is it right? Okay. Okay, now let us talk about the three forces. Okay, all the three forces which I've already told you. One is the gravitational force, the other is the force of buoyancy, and the third one is the viscous drag. Okay, so all the three types of forces, we are going to understand them from a mathematical point of view. Okay, mathematical expression we are trying to derive for them. Okay, and then we are trying to also equate the three forces. Okay. Yeah. So coming to this again, gravitational force. Okay. Gravitational force acting on a particle is Fg is equal to mass into the acceleration due to gravity. Okay. Mass into acceleration. I think you already know this formula. Okay.
Yes, sir.
Force is equal to mass into acceleration, but because we are trying to understand the particle which is in a liquid, okay, and it is trying to settle down to the bottom, and that is dependent upon the gravitational force. Okay, so instead of writing mass into acceleration, we are writing here mass into the gravitational acceleration, right? And therefore this mass is in terms of kilogram. Okay, and the acceleration due to gravity is in terms of meter per second square. So you are aware about this term also, meter per second square. Okay, then we come to bacteria. Now bacterial cells, because they have a certain density, bacterial cells are not like a piece of iron, isn't it, or a iron particle, isn't it, which is a very heavy particle and it is completely dense particle without any you can say space in between. Okay, bacterial cells, you know the structure of bacteria. What is the structure of bacteria? They have a cell wall, then they have a cell membrane, and what else do they have inside the bacteria? What is
Flagella,
there?
pili, fibri,
Okay,
flagella, pili, fibri.
flagella, pili. Then what is inside the bacterial cell? Within the membrane,
Cytoplasm.
Floating chromosome, that is
Mitochondria,
nucleoid.
DNA,
Nucleoid.
nucleus.
मायटोकॉन्ड्रिया कशात असतात? बॅक्टेरियात असतात का?
नाही सर,
नाही नाही
न्यूक्लिओइड
sir.
असतात, रायबोझोम्स असतात,
Nucleus, sir, nucleus.
Nucleus.
न्यूक्लियस असते बॅक्टेरियात?
रायबोझोम्स,
अरे मला नवीन नवीन
न्यूक्लिओइड,
concept.
न्यूक्लिओइड सर, फ्री फ्लोटिंग क्रोमोझोम, that is nucleoid.
Okay. But all this is present in what? In an empty space, isn't it?
Yes,
तुम्ही हे सांगायला
peptidoglycan membrane.
एम्प्टी स्पेस महत्वाची आहे, तुम्ही विसरताय सांगायला.
Matrix, sir.
एक I had somewhere I had heard a very nice saying actually. Okay, what was that saying? The meaning of that saying was like this, that the emptiness, okay, emptiness which is present within a particular material, that is very important. Okay, because of the emptiness, different things have different properties. For example, that there was in that saying they said that the say 30 spokes of the wheel. Okay, you know what is a wheel? Wheel
Yes, sir.
म्हणजे चाक. Okay, cycleचा चाक. Okay, wheel, and this cycle wheel has spokes in between. Do you know the spokes are there? Okay,
G.
माहिती आहे ना? तर wheel and the spoke is there, that is there, but the emptiness which is there within that wheel, that emptiness is something very important, and that gives the wheel its characteristic, you can say, shape also, and the characteristic, you can say, the properties of the wheel, that is the property of moving, isn't it? That is because of the emptiness which is there in the wheel, right? So you can take the example of any container, container made up of gold or container made up of steel, stainless steel. Okay, the emptiness which is there within, that emptiness helps you to keep something in that particular material, in that thing, container, isn't it? So here in case of the bacteria also, the bacteria has different structures or different organelles. Okay, but the